Hey folks, in this video we are going to talk about the concept of inheritance and how it applies to object-oriented programming and how you might go about using that on your day-to-day basis. So you'll remember that the whole point of object-oriented programming is so that we're trying to model the real world. And the real world is made up of objects. I'm sitting here at a desk, which is an example of a table that has a surface and it has some drawers and some functionality. There's a telephone sitting here and a computer, and each of those are physical objects. If we were to mimic this in an object-oriented manner, each of these would be a literal object, as far as an object-oriented program is, of class, telephone, or computer, or desk. But when you think about that for just a few minutes, you realize that there are inherent relationships in the world where a telephone is not always the same thing. So if I were to pick up the telephone that's here on my desk and show it to you, that is a telephone, but it's a desk phone. And that's quite different than if I were to pick up my cell phone and show it to you, which obviously is a cell phone. But they're both phones, and they both have a number of functionality that's the same. They also have some things that are unique to each of them. For example, my cell phone has the ability to surf the web and get messages and do things that the desk phone doesn't have the ability to do. But my desk phone has the ability to dial other extensions in the university, which my cell phone doesn't have the ability to do. But having said that, they both can make phone calls, they both can contact voicemail, they both can dial numbers, and so on and so forth. They have attributes like the desk phone happens to be black in color, whereas my cell phone happens to be white in color. The size might be different, and so on. So inheritance allows us to define what all phones have in common, and then we can create subclasses of that phone class that are specific to each of the different types of phones that you might run into. One type might be a desk phone, one type might be a home phone, one type might be a cell phone, one type might be a call box, or something that might exist out on the side of the street like an emergency call box. So that's the idea of inheritance. So when you're dealing with object-oriented programming, inheritance allows you to absorb some of your parents' memberships, such as their attributes and also their methods. Inheritance saves time and allows you to reuse code. And what does that really mean? So we've talked about in previous examples, when we were writing methods, I mentioned that you shouldn't really be rewriting the same methods over and over again. Once you've figured out how a method is supposed to work, you write it once in a given language, and then you would probably just reuse it every time that you need it again in the future, because why would you debug it over and over and over again? There is a disease that a lot of people suffer from, especially people who come straight out of college, and it's called a computer science disease. And really what that boils down to is you kind of have this sense that you should reinvent everything from scratch because you're going to do it better than somebody else. And while I have zero doubt that you guys are all incredibly smart and incredibly capable, the reality is rewriting the same thing over and over again actually just makes more errors. The chances are that the old code that exists probably solves some of the errors and some of the weird fringy conditions that you're probably not going to think about while you're coding this. So let's take an example. We had the idea of circles and triangles and rectangles in one of your recent labs. And something that you were being asked to do was to calculate like a circumference. Well, the circumference of a square versus the circumference of a rectangle versus the circumference of a triangle versus the circumference of a hexagon are actually all the same code. You just need to add up the size of the sum of all of the sides to get its circumference. Now, when you calculate a circle, it's a little bit different than that. But it would be fair to say that you could one time create a class called shape, and it could have a method for calculating circumference. And all it would do is it would look at all of the sides, however many of them there may be, add them up and return the answer. When you get to the circle, you're going to have to change what it means to calculate the circumference. So rectangle and square and hexagon and all of those numbers are going to just inherit from their parents some circumference, but circle's going to have to rewrite that, and you're going to have to rewrite new code for how that works. Once that's been done, you would never really rewrite that again. And when you work in a company, you're going to work with other people, and they're going to write code as well. And you're going to use their code, and they're going to use your code so that it's not constantly being rewritten. In most of the examples that you deal with in classes, we're only asking you to write a couple of hundred lines of code at the outset. But that's really not how it's going to work when you get to a job. You're going to be writing thousands or millions of lines of code. And clearly you can't do that from scratch every time, Like if you take a new game that's coming out, it doesn't make sense for you to rewrite the gravity engine. Well, gravity is still the same. Unless there's something weird about this game where you're altering how gravity works, you're going to inherit the same gravity engine that every other game made by your company uses, because it does the same thing. So that's an example of reuse. You should get in the idea that every time you possibly can reuse something, you should. The only time that that's really not the right answer is if you're writing a test for a class and you're copying somebody else's code. Then it's not allowed. But in every other circumstance in the world, we would actually prefer that you reuse code and you modify it to make it work the way that you want it to. Okay, so let's take a look at an example. And the first thing that I'm going to talk about is this little drawing over here on the right-hand side. This drawing is actually a specific way that classes are going to be defined. And it's called a UML diagram. So Universal Markup Language. And basically what you're doing is you're listing all of the things that are true about a given class. So I'm just going to read this one off to you. This is a class called Mammal, and I know that because it's in the first top part of the box. So the upper box is going to be the name of the class. In the next box, I can tell that this mammal has 4 attributes: temperature, weight, IQ, and fur color. And I can also tell that it has 4 methods: eat, drink, move, and give birth. The pluses and the minuses that are here are actually telling me whether they're public or private attributes. These are privates, these are publics. I know these are methods because they have the parentheses, and also because they're in the third box. You put the methods in the third box, the attributes in the second, and the name of the class in the top one. So this is one class, and it's just a standardized way that you would write your class. And why would you do this? Like, why would we need this? Well, if you think about a game company again as an example, there's going to be millions or at least thousands of classes that are being used. Each character in the game, good guy or bad guy, is going to have a class representing it. Each object in the game that can be picked up or inventory are each going to have classes. There's going to be classes explaining how to do the graphics, classes explaining how to do the AI, classes explaining how to run the gravity engine, and so on and so on. There may be classes for dealing with the network if you have the ability to play multiplayer across the internet. There may be classes for dealing with some central database where you keep track of high score. There could be hundreds or thousands of classes. And for a new developer who gets hired by this company, that's very overwhelming. They don't want to have to go and sit there and read thousands of lines of Java code. So instead, each class will be listed in a UML diagram that's typically up on the wall somewhere in the development area. And so if you have a question about, how do footballs work in this game, you can go over and you can stare at this big chart until you find the football class, and then you'll be able to see all of its attributes and all of its methods. And whether it's on a wall or whether it's accessible electronically, it doesn't really matter for this example. You will typically find this. You'll also find that when developers sit in a scrum and are talking about what they're going to do this week, they'll frequently use a UML diagram to show what it is that they're going to build. It's just a standard way of people talking. So you definitely need to get used to the idea of drawing a UML diagram. All right, so I had this mammal class, and now I need to make a dog class. Well, one option is I could go off and I could create a dog class, and I could basically copy and paste everything that was over in the mammal class into my dog class, because it turns out dogs also have temperature and weight and IQ and fur color, and they also need to know how to do all these things because, well, dogs are basically mammals. So one option here would be I create another class and I copy and paste all of the code over. And that would work. But then what happens if I need a class for cat and elephant and boar and cow and 5 other mammals? Then I would be copying that code into a lot of different places. And here's the kicker. If at some point we change how they move, and you might say, well, how would you change how an animal moves? Well, for example, it may be that these are all creatures that are walking around inside of a game. And the move method may have previously been based on, let's say, a 2D array. So the world is laid out in grids, and if the dog is in this area, then they're going to be in a particular cell in the 2D array, and when you move, you allow them to move this way or you allow them to move that way. Well, what happens if you suddenly decide that you want to allow the dog to move diagonally? Well, if it's just the dog, that's not so bad. You come into the dog method and you update the move method. But if I need the dog, the cat, the boar, the cow, and every other mammal to be able to move diagonally as well, I would have to go make that change in dog, then make it in cat, then make it in elephant, then make it in boar, then make it in cow, then make it in the 500 other ones. And who can even remember what all of those classes were that we wrote? This is very bad. It's called maintainability of your code, and it is bad maintainability. Very specifically, the problem here is you have basically the same method that's being used for different animals, and you're having to maintain it in each of the animals separately, even though it's doing the same thing. This is going to lead to problems. You're going to make mistakes. You're going to forget to do it in one. When you copy and paste, you're going to introduce bugs. It's all a big disaster. So how do we get around this? Well, you don't do this. You don't make a dog that has all the same attributes and all the same methods. You instead use inheritance. So this is an example of a UML diagram where we're talking about inheritance. So we put all of the methods and all of the attributes up at the top in Mammal. We specify that it has all these attributes and it has all these methods. And then we create a child class or a subclass or a derived class of Mammal called dog, and we say the dog inherits from Mammal. Likewise, the cat inherits from Mammal, and the cow inherits from Mammal. So very specifically, this arrow that's drawn here is literally part of the diagram system, and it means inherits from. Dog, cat, and cow are all examples of Mammal. So there are a couple of things to ask about all of this. Note that the dog has no attributes and no methods, and likewise the cat doesn't, and likewise the cow doesn't. That may be true. It may be that in actuality dogs, cats, and cows, for the purposes of our game, maybe they need only the same attributes and the same methods. It may also be that dogs also have some other capability, so they can fetch, whereas maybe cats can't fetch, but maybe cats can play with a ball of twine, and maybe cows can do whatever it is that cows do. So you could have unique methods in each of the child classes in addition to the methods that they all inherited from their parent. So to be clear, once you've created this dog class and you've specified that it inherits from Mammal, immediately in your code in the dog class, you can start setting your temperature, your weight, your IQ, and your fur color, even though none of those attributes appear in your class. And the reason you can do that is because you inherited all of those from your parent, which brings us to the question. In that previous diagram, how many attributes does the dog have? One answer would be none, because there's nothing in here, and that would be incorrect. The correct answer is the dog has 4 attributes, because it inherited those 4 from Mammal. Likewise, the cat has 4 attributes, and likewise the cow has 4 attributes, and all 3 of them have 4 methods as well. So there we go. So what happens if you want to do something that's specific for your one of your creatures? So your dog, as I said, wants to be able to fetch. Well, that's okay. You can write methods inside of the dog class that are unique to the dog. If you have something that all of the mammals are going to need to do, you should put it in Mammal, and then all of its child classes will inherit it. But if it's specific to one child class, you just write it in the child class. So the location of where you write things is now important. So each one of the children can have their own additional attributes and their own additional methods, and that's perfectly valid. It's also possible that you might need to override some of the methods. So let's go back and take a look at this. And we're going to pick a particularly weird thing here. So it may be that the way that dogs drink is different than the way that cats drink. And to some extent, that's true. If you slow down a dog drinking water, what you'll see is that in the bowl of water, they basically smack their tongue against the water and make it jump up in the air, and then they grab it. Cats do it ever so slightly differently. So the method for drink may be different for dog and cat. Well, how does that work? Because they all inherited drink from Mammal. And the answer is, in dog, you would override drink, and in cat, you would override drink. That, since there is no override in cow, it will do whatever the Mammal version of drink is, but since you overrode it in dog and cat, they will each do their own unique version of drink. So it is possible to override a method in one of the children. So what does that have to do with overriding versus overloading, which is something we've talked about in a different video? Well, the answer is they're quite different concepts, and you need to keep them straight. Overriding really has to do with inheritance. It means that there was a parent that had some method, and we need to change that method ourselves, so we're going to override what the parent told us. Overloading means that we have more than one method with the same name but different parameters, and that was something we talked about earlier. All right, so there's a couple of terminology things here. A dog is a mammal, and the phrase is a useful phrase that you're going to use anytime that we're dealing with relationships that are inheritance. So dogs really are mammals. Cats really are mammals. And in this UML diagram that we were looking at, that is also true. Because there is an inherited relationship from dog to mammal, we would say that the dog is also a mammal. Mammals, which are the top class, are sometimes referred to the parent class, and that's the word that I will use most of the time in these lectures. I'm going to call them parents. And then the children are children. The dog, the cat, the cow, those are children classes or child classes. That's typically the words that I will use. But it's also valid to call them base and super for the parent, and derived and sub for the child. So you could say mammal is the base class, cow is a derived class. You could say mammal is a superclass, whereas cow is a subclass, or you could say mammal is a parent class and cat is a child class, or any combinations of the above. They're all valid ways. So let's take a look at some actual code here. So we have class mammal, and it has two public attributes. We have float for weight, and we have int for IQ. And then we have a new class. And this is the new syntax that we haven't seen before. We say class dog, which that part is not new. In C# we use this colon, and then we specify the parent class that we wanted to inherit from. So this would be read, class dog inherits from mammal, and class mammal is defined up here. Note that this doesn't go inside of this or anything like this. They are written separately, and the compiler understands that I now need to go look up mammal, and I'm going to inherit all of its attributes and all of its methods. So in this particular case, the dog class immediately has access to weight and IQ that it can modify down here. And each dog will have its own version of that weight and that IQ. So now we do the usual thing that we've always done, which is we instantiate a dog. So we say dog D equals new dog, and that's going to create a dog. You note that there's nothing different in the syntax down here because it's an inherited class. It doesn't change anything. This is still exactly the same syntax as it was before. I'm just making an instance of an object dog, and I'm assigning it to a variable called D, which is of type dog. So this is the C# syntax, and again, it's a colon, and I need you to remember that colon. That's going to be important. Over in the Java world, that colon is replaced by the word extends. So dog, class dog, extends mammal is the equivalent code in Java. And so this does exactly the same thing. The dog now has access to the weight and the IQ, and when you create a new dog, it's the same syntax as you would have always done. All right, can there be more than one inheritance? And the answer is yes, in every direction. What I mean by that is we could have a class Labrador, which extends dog, when dog extends mammal. There could be a hot-blooded class in there. So you have mammal, which has a subclass of hot-blooded, which has a subclass of dog, which has a subclass of Labrador. There could be 3, there could be 4, there could be 500 layers to this. And it depends on what it is that you're trying to model in the real world, and would you actually need to be able to instantiate all of those different things, or can you just munch them together? So the answer to the question, well, how would I know how deep my hierarchy should be, is it depends on what you're trying to do. If you are only using dogs and mammals, then 2 is probably fine. If there are things that are specific about Labradors that you need to have their own methods and their own attributes, then maybe you would have a subclass of dog for each breed of dog. And maybe there could be a subclass of that for, the sex of the dog, or for the size of the dog, or whatever it is that you may need to do. So it depends on what it is you're trying. You would definitely say a Labrador is a dog, and a Labrador is also a mammal. So it is fair to say that Labradors are dogs and Labradors are mammals, because they are all in that same thing. And it is also the case that Labrador will have access to the fur color. All right, So this is a thought-provoking question, and we're going to come back to this in more detail later on. So in this example, we talked about mammals, we talked about dogs, and we talked about Labradors. When you pictured in your head a Labrador, you probably pictured what a Labrador looks like, if you know what a Labrador looks like. And when you pictured a dog, you were probably able to picture a dog pretty well. But when I say mammal, what did you actually picture? And the answer is something. I mean, it's a very vague class name. We wouldn't really ever say that you have run into a mammal. You would say, well, I ran into a bear. And so mammal isn't really something that exists in the real world. Object-oriented programming is all about modeling the real world. So it's unusual that we're going to deal with these high-level concepts that sometimes don't really exist in the real world. They exist for the purposes of all mammals need to be able to sleep and all mammals need to be able to walk, and it might make sense to implement all of that at the mammal level rather than re-implementing it in each of the individual mammals. So that makes sense from a coding standpoint, but that doesn't necessarily mean that you'd ever actually make a mammal class or instantiate a mammal class specifically. So this might be the idea of an abstract class, and we're going to spend a whole day talking about that at some point in the future. But I just wanted to plant the idea in your head that some classes are not really going to actually be ever used in the real world. Another thought-provoking concept, which we'll come back to again, is the idea of polymorphism. And this is a concept that comes up a lot. It's very important. There's going to be a whole lecture on it later. But the idea here is a dog a dog? Well, yes, it is. Is a cat a cat? Yes, it is. But is a dog a mammal? Yes, a dog is a mammal. Even though it's also a dog, it is also a mammal. One thing can be more than one thing. And that's the idea of polymorphism. I'm just going to plant that seed and I'm going to move on quickly. And in a later video, we're going to spend a lot more time talking about that idea and why it's useful. So let's talk about some of the details of how we would go about doing this. So I'm going to switch off of here and I'm going to run over to Replit. And I'm going to start a new Replit. And I'm going to do this one in Java first, and then the C# version is going to be sitting out here as well. I'll show it to you at the end. Okay, Java, there we go. All right, so what we're going to do here is HERITANC, Java. All right, what we're going to do here is we're going to talk about the concept of a classroom. So if this was a physical classroom, it is made up of desks, me, you guys, and maybe there's some other things that are in here. So how would we model this in the real world? Well, it might be that everybody's desk is in a specific location, and maybe we model that as a 2D array. That's a common idea. So the classroom is a 2D array, and I'm just going to draw this out so that you can see what I'm talking about here real quick. So every desk is generally in a row and a column, and so it's quite common that what you might have is the room is laid out as if each desk is in a cell in a 2D array. So, there we go. Here is our classroom, and we have desks. We'll do it like this. And I think you get the general idea here. So I'm not going to draw all the circles, but you understand that there are rows and there are columns of all the desks. All right, so if I wanted to model this in computer code, it's likely the case that I would need to use a two-dimensional array. And so, for example, this guy right here would be known as perhaps 0, 0. And what I mean by that is that this is the 0th row, so row 0, and this is the 0th column. All right, and so this guy next to him would be 0, 1, and this guy would be 0, 2, and this guy would be 1, 0, and this guy would be 2, 0, and so on and so forth. And then there's going to be a place for the instructor up top, and so maybe you'd have to add an extra row up here or something in order to account for them. All right, so why would we do this? Well, maybe we want to keep track of where everybody is sitting in the classroom, so that I can know when somebody raises their hand what their name is, because I would know they're in a particular seat. So each of these circles would be a person. And there would also be a person up front, which is me. And people all have common attributes. For example, every person in the world has a name, pretty much. They all have a weight, they have a height, they have attributes about what they do for a living and what departments they're in and what major they are and so on and so forth. Some of those are specific. So students have a major, but teachers don't really have a major. And department might be arguable as well. Students maybe have a department, but realistically, teachers definitely have a department, right? I teach for the software engineering department versus somebody who teaches for the civil engineering department. So each one of these cells is going to be for a person. Sometimes the person will be a student, sometimes the person will be a teacher. So let's jump over to our code and let's start talking about people. So I'm going to make a new class, and I'm going to call that new class person. Person.java. And so in here, I'm going to say class person, and let's give attributes. So they're going to have a name. I'm going to make these all public for now. I'm going to give them an X location, which is going to be an integer. All right, that's the location of their seat, effectively. And I'm going to give them a Y location as well. And then maybe I give them a direction, which way they're facing. So we'll call that a character, and we'll call it facing. All right, and then we're going to need a constructor for person. So we're going to say a default constructor, so public person, takes in no parameters. We're going to set their name equal to blank. Tell you what, let's set their name equal to unknown. And we're going to set their X location in general to 0. So everybody starts off in the top left corner for X and Y, and we're going to set their facing equals, let's do north for everybody. All right, so that's going to be our default constructor. Probably useful to have another constructor that actually takes in all of those parameters and then gives us the actual, sets the user up correctly. So we'll take in a string for name, a integer for X, an integer for Y, and a character for F for facing. So now, instead of the name being unknown, it's going to be N. The location for X is going to be X. The location for Y is going to be Y. And facing is going to be F. All right, so far so good. We have two constructors for our person class. So let's talk about somebody being able to move, because it's a reasonable thing that somebody might want to be able to do. So we're going to say public. We're going to make this a void. It's not actually going to return anything. It's just going to move them. And we're going to call this move forward. And maybe we'll take in a distance. All right, so let's talk about in our picture here, what does it mean to move forward? Well, let's assume that this is the front of the room up here. And that is an R, good Lord. And that's an F. Let's assume this is the back of the room. So moving forward would mean that you're moving this way. Whereas moving back would mean that you're moving that way. All right, so if we define that this top is 0, 0, and we count it in that direction, then moving forward means that your row coordinate is shrinking. So if you are at the back of the room and you're moving forward, you're going to go to a smaller X coordinate. So I'm going to say X location minus equals distance. All right, well, if we know how to move forward, it's not a big stretch to figure out how to move backwards. And so in that case, your X location is going to be plus equals distance. And if we know how to move backwards, well, maybe we want to be able to move right. So in that case, your Y location is going to change. And it looks like from the diagram that if this was 0, 0 over in this corner, then a larger Y means you're moving to the right as per this diagram. And of course, it depends on which way your perspective is. But for this example, we're just going to assume that it's to the right. And then we're going to do one for moving left. And we're going to set that person's Y minus equals the distance. Okay, so we have given the ability to move. The final thing we're going to do here is I'm going to go ahead and override toString. So I'm going to say at override public string toString. And what I'm going to do is I'm going to return my name is, and then we're going to return the name. and I'm located at position X, comma, Y. Okay, so if anybody tries to print out a person, we'll at least be able to see where they are. Cool. All right, so that's a reasonable definition for a person. Let's go ahead and make a student. So I'm going to make a new class, and I'm going to say student Java is the name of the class. All right, so that's our first syntax difference. I said student class extends person. So what's happened at this point is a student now knows how to move left, right, up, and down. They have an attribute about where they physically are located, and they have the basic ability to get around and do things. I can also go ahead and I'll make another class called teacher, and I'm going to do the same thing in there. Teacher extends person. Likewise, now teachers exist as well. So over in my main program here, I've really done nothing with any of these people. I'm going to make a new teacher. So I'm going to say teacher enda equals new teacher. All right, and I'm just going to run and see what happens. Do we get any compile errors? Did I miss any semicolons in stupid places? Now is a good time to go find all of that and debug whatever nonsense I may have done with regard to that. And sure enough, I did. So it looks like in person on line 39, I have an error about, well, because it's called X location and Y location. And the same thing for there, they're not actually called X and Y. So I'm just going to recompile and see if that solves that problem. And I mean, I would not expect this to output anything. I still get my hello world, but I have successfully created a teacher in there. So what I'm going to do is I'm going to ask it to try and print enda, and let's see what happens here. So you'll note that when I created enda, I didn't pass anything in as parameters to the constructor. So effectively, this is going to try and call the default constructor for teacher. And you might say, did you write a default constructor for teacher? And the answer is no, I didn't. As a matter of fact, you'll notice in here, teacher actually has no methods. But all of a sudden, I got output. My name is unknown, and I'm located at position 0, 0. So how on earth did that happen? Because in main, to be clear, all I did was I created a teacher. I named the variable enda, but that has nothing to do with anything. I could have named it X, and it would have been fine. And then I simply printed it out. Magically, that person has a name and a location. And the reason is because teacher extends person, and person has attributes of name, location, and facing. And since I called the default constructor in person, which wasn't there, it did nothing because there's no attributes locally in teacher to set. It also will call the default constructor in person. Now that's a little bit new and confusing because I never called person. To be clear, in my main method, I said nothing about person. I simply said teacher enda gets new teacher. So why are these attributes in person being available, and why did a constructor run in person? Because we can tell this constructor ran based on the fact that the name is unknown. Well, the answer is when you create an object, if that object inherits from some other object, which, spoiler alert, all objects inherit from some other object, and I'll talk about that in the next video, every constructor in the chain from the bottom all the way up to the top is going to be fired in order. So to be clear, in main.java, I said teacher gets new teacher. This attempts to call the default constructor in teacher. There isn't one, so it makes one up, which has no attributes to set, so it does nothing. Then it realized that teacher extended person. And since I call the default constructor in teacher, it's going to then call the default constructor in person. And up here, the person one also fires. So the teacher's attribute for name and X location and Y location all got set. That teacher named enda has an X location, a Y location, and a name, all because of inheritance. Even though the class doesn't have those variables in it, it has access to them from its parent. So I hope that makes sense, And that's the basics of inheritance. There is a lot more that we're going to talk about, and I'm going to break it up into another video because there's a lot of weird gotchas that you can talk about here. But I want you to get the very basic idea from this video. And it's a very important idea because it is going to be the fundamental feature of everything that we talk about for the next 3 weeks. That any class that you want can inherit from another class. That is done with either the extends keyword, or if we're over in C#, the equivalent is done here. I guess I called it instructor instead of person. I'll modify that just so that they're consistent after this video is recorded. But the colon is what does the extends in C#. The way that inheritance works identically between the two languages. All attributes that are available in the parent are now available to the child, with one little footnote, which I'm going to come to in another video, that it has to be allowed in order for that to be true. You could have an attribute that is not allowed to be seen in the child, and that's done through the public and private keywords. So we'll talk about that in another video, but don't worry about that for now. In general, as long as the method or the attribute is public in the parent, the child will have access to it inherently. It will have its own copy of that and has the ability to change it in itself, regardless of what happens in its parent. So I hope this makes sense. This is the very basics of inheritance. There's going to be a lot more videos on specific topics related to inheritance coming up, so check those out next. We'll see you soon.